Hi there, so let's go through the C++ Essential 1 Module 4 exam. Now, the first thing I want to say is don't use this video to cheat, only watch it when you've given the exam a really good go and you just want to come and check for my explanations to the solutions. Also, if you'd like to download this PowerPoint I'm working through, then you can. I will leave a download link for you to do so in the description below with all my annotations on. Okay, so question 1 is all about concatenating. And first of all, we make a variable s equal to the string a, and then we go ahead and try and add this s string to the output string with these double less than signs. So these add to output stream. Now, there's sort of a difference between these adding to the output stream and the plus operator. Now, this is concatenating. So concatenating is just with the plus operator, and hopefully you should know that concatenating can only be between string and variable, or the other way around, variable or with variable, and most certainly not string to string. Okay, so for string to string like that, this is forbidden. Okay, so a plus c is forbidden. Okay, let's just say the variable s plus the letter a, that's allowed, or the variable s concatenated to the letter s, that's also allowed, but we can't concatenate a string directly to another string. They've got to be stored in variables. And so the result of this program is a compilation error. Okay. Now, the next question, question 2, is about the modulus operator inside of C++. So first of all, make an integer I equal to 2 and a float f equal to 4.4. And then we try to calculate the modulo of a float with a float, because this static cast converts I from an integer to a float. So it's between a float and a float. And the modulo can only be between two integers, so int, modulo, int. Okay, it can't be between any floats or obviously strings or anything like that. And I've not tried it myself, but you can probably do a character as well, since characters are kind of considered as integers. And so the output of this one is another compilation error. Now let's go through the next one, question 3, and this one is about the string swap method. Now I've got string s1, which is aleph. We've got s2, which is alpha. And we've got s, which is nothing. And I'm just going to represent nothing with a dot. And then we go ahead and swap s1 with s2. And hopefully I don't really need to explain what swap does, but it takes the contents of s1 and moves it to s2. And it takes the contents of s2 and moves it to s1. So now s1 is alpha and s2 is aleph. So nothing to do with s3 at this point, we're just swapping s1 and s2. But now we swap s2 and s, so aleph goes to s and nothing goes to s2, so s2 is aleph and s is nothing. And then we go ahead and swap them back again. I don't know what the point of, well, obviously the point is just to trick you doing two swaps. But this one goes here, this one goes there. So we're back to aleph here and nothing here. And s2 is obviously going to be aleph. So the output of the program is aleph. Okay, the next question is about extending namespaces. So we make a namespace s and we define a variable a in it first of all, so a equals 1. And we're adding a variable b to it to store a, which is 1, plus 2, so it becomes 3. And then what we're doing is inside of our main function, we're tapping into this s namespace and we're accessing the a variable inside of here. And we're setting equal to itself plus 1. So we're incrementing this to 2. And then what we do is we enter this block where we use the namespace s. This basically says that we don't have to explicitly say, okay, we are referring to s. S is b. We don't have to do any of that if we just explicitly say that we're using this namespace. Okay, so we're incrementing b from this s namespace to 4. And then we output b followed by a, therefore we output 4, 2. Not 42, but 42. not 42 but 4 followed by 2. Okay, let's move on to the next one. Again, it's about using namespaces. Again, it's about namespaces. This time it's about how we can use a namespace. So first of all, make S1 to store the variable a as 1, and then make S2 to store the variable a as 2. Okay, and then inside of this block, we explicitly say that we're using this S1 namespace. Okay, and then what we do is set S2's variable a, which is this one, to S1's a. Remember, because if we say nothing, we've already used this namespace. So S1a goes here, but we don't have to say that because we've kind of already said it, if that makes any sense. So S1's a plus 1, 1 plus 1 is 2. So we set this to 2. Let's just reset my zoom. So I'll just cross it out and say 2. I didn't have to do that, but I did anyway. And then we, all this is enclosed in a block. Okay, so we've only used this namespace within the block. Okay, so outside of this block, we're not using the S1 namespace anymore. But then we enter another block in which we use S2 namespace. So that means anytime we refer to the variable a, we are implicitly referring to S2a. Okay, and then we again set S1's a, which is this one right here, to S2's a plus 1, so it becomes 3. And then we output S1's a, which is 3, and then S2's a, which is 2, so we output 32. Okay, this is question 6 about string methods. So we've got the string s equal to the string ab. Okay, so we've got ab stored in this string s, and then we say s.append s, and this append is going to add item to a string, and in this case we're appending ab to itself. So AB is the result of this so far. So we're taking this string AB and appending itself to itself. So we've got AB. And then what the pushback does is it adds item, which can be a character or string, to the back of the string it's called on. Okay, and in this case we're using this square bracket notation to pick a value from this s. Remember, this s is a string so far, so we've got AB, and each item inside of this s variable has an index. Okay, so the index starts at 0, so the first item in a string has an index of 0. The second has an index of 1, then 2, then 3, okay, and so on. For example, if I was to pick out s and then in square bracket state the index 2, can you guess which item I'm going to get back from this? Will be A, wouldn't it? Because the item at index 2 is A. Let's rule this out because that's not what we're doing. Instead, we're getting s.length, which is 4, minus 1, which is 3. So s at index 3 is this last character. So anytime I see like a string and then a subscript and then the string's length minus 1, I already know that we are getting the last character from it, okay? Just because s.length is the number of characters inside the string, and this is going to be 4, isn't it? But then we have to decrease this by 1 to take into account the indices start at 0. So this is going to push to the back the result of this, which is B, okay? So we're going to push to the back B. And then, of course, output S, which is A, B, B. Let's move on to the next one, which is all about pointers in vectors. And I did give this a few goes myself and get it wrong. And first of all, we make an ft variable equal to a vector, in which each item in the vector is going to be a pointer to a float. Okay, so we are first of all making 3 items in this vector with this new keyword, so that's going to make a pointer to point to something, and it's going to be an array of floating point values, and specifically 3 floating point values. So let me go and have my array, and each item is going to be initialized to 0. So we've got 3 of these arrays with 0 as the items in them. And then after that, what we do, make that one tiny, is we go ahead and make a pointer P to point to a floating point value, and we'll first of all point to nothing. That's what this null pointer does. This points to nothing. And then we enter this for loop. So we first of all make I equal to 0, and then it's going to be increased by 1 to 1, and then it's going to be increased to 2, and then it's going to be increased to 3, but the for loop's not going to run that time, is it? Because 3 is not less than 3. So let's take I equals 0, so P equals ft at I. Now when we say P equals, so we say a pointer equals something, we're essentially saying we're essentially pointing P to a memory address. We've got P and we're saying ft at I, so I is 0, and the same kind of thing as with a string. We can subscript a index of the vector. So the first item in the vector, this array, can be accessed through the index of 0. And whenever we set a pointer to an array, it points to the first item in the array, so this one. We are setting the pointer to point to something. And in this case, it's this array, or the first item in the array. So pointing to the first item in the array. Okay, and then what we do is we use this asterisk. And what the difference between this P equals and asterisk P equals? This asterisk P equals is something called dereferencing. And what this means is we're setting the value that the pointer points to. Okay, so for example, in this case, if P points to this item, and I was to say set the value pointed to by P to 5, then this item would become 5. I'm not going to write that in because that's just an example, not doing that. And then what we do is we use a subscript again. Now, it's kind of confusing, they're trying to trick you because P, there's two kind of syntaxes. So P square brackets offset. I want to say offset, I mean how much it's offset in memory, so whether it's the next memory address over from the current one it's pointing to, or the next two memory addresses over, etc. So P square brackets offset is equivalent to asterisk bracket P plus offset. Okay, and those two are the same. So I just wanted to clear up what all that means. As you can see, I've got multiple equal signs, all right? So I personally like to take the last equal sign and evaluate it first. And 10 times 1 is always 10, so I'm just going to get rid of that times 1. It doesn't matter, it doesn't mean anything, okay? And essentially what we're doing here is we are taking P and we're offsetting it by 2 places in memory. So we go 1, 2 to point to the 2 memory addresses over. And then we're setting the value pointed to, so it points to here now, and we're setting the value it points to 10. Okay, so let me just add that 1 right in there. I did leave myself enough room before the zeros. And I've already said this is equivalent to this. So P offset by 1, so it points to here, so now we're going to offset here, is equal to, the result is equal to 10 also. So I'm going to put 1 here as well. And then what we do is we set the value pointed to by P. Okay, so P directly. So we're not trying to offset it by anything, but P points to this one. So we're going to set the value that P points to 10. Okay, so hopefully we can all see that. Now let me go ahead and get rid of all my arrows because we won't need them when I is equal to 1. So when I is equal to 1, P is pointing to, we're going to point P to the second ft item, which is the first item in this array. And then what we're going to do is we're going to do exactly the same thing. So P offset by 2. So P plus 2 is going to offset P by 2. So it's going to point to this one now. Let's just draw this in black. And the value, we're going to set the value pointed to, and we're going to set the value this points to 10. And then we're going to set the value of P offset by 1. So P originally points to here, so we're going to offset it by 1. We're going to set that to 10 as well. And then we're going to set the value that P points to 10, just like so. And hopefully you can use your imagination and logic to guess that, not to guess that, but to realise that P is going to point to here when I equals 2. and then when we offset P by 2, it's going to point here, and when we offset it by 1, it's going to point here, and we're going to set all of those equal to 10. So everything in here is going to be 10, and then we're going to output ft at 1, which is this one, and then we're going to drill down further into the first item of this array, which is 10, okay? And then we don't have to worry anything about deleting, okay? So that doesn't output anything, and the questions are always about what's the output of a certain program. So anytime you see delete, just ignore it, okay? Leave it scribble out. All right, now on to question 8 about substrings, which is significantly easier than that last one. But first of all, we make s equal to the string 0, 1, 2, 3. And then what we do is we use the substring method 3 times on it. So what does it mean if we pass in substring or subster, with 2 values? What are these 2 values? So the substring, if you know, is like a slice of a string. Okay, substring is a part of the string. So substring at, so when you say substring, you can pass in the index of start character in the substring, and also the length of substring So we're going to start the substring at index 1. So we already know characters have the indices starting at 0. So this one's index equals 0, 1, 2, 3. Fairly obviously, well, yeah. 2, 3. And then what we're doing is we're starting the substring with this character, okay? So it's going to be 1, and then the length of the substring is 3, so it's going to have 3 characters starting from this one. So it's going to be 1, 2, 3 characters. So this one is going to give 1, 2, 3, okay? Just without the 0. So hopefully we can all see that the substring is going to start from the second character from the string it's called on, and the substring is going to be 3 characters long, so it's 1, 2, 3. And then what we do is we chain another substring onto it with 2. Now what a substring does if we pass in only one value is it will access from this start index onwards. Now in this case, 1, 2, 3 substringed with 2. This has an index of 0, this has an index of 1, and that has an index of 2. So we're going to start at 2, and onwards is nothing, okay? So we've got 3. And then what a substring does with nothing provided is it will output the original string. So in other words, there's no point of it, okay? So for example, a string hello dot substring with nothing provided is going to be hello. Okay, so the output of this is 3. Okay, so now let's move on to question 9 about data types. And to begin with, we make a short integer equals 1. Remember that short is just an integer, just with less memory allocated. A short has 2 bytes, whereas an integer has 4 bytes. Okay, so short is an integer. And similarly, a double is just a float with more memory allocated to it. And then what we do is we output s, which is 1, divided by I, which is 2, is a half, of course. But because we're doing integer divided by integer, we're going to get back an integer. And an integer, whenever we try and convert a float to an integer, we always round down. Okay, so in this case it's 0. And then we do f, which is 4.4, divided by I, which is 2, is going to be a half. And doing a float divided by an int is going to give back the float. So it's always going to try and preserve the fractional part if it can, but if it can't do because they're integers, then it won't. So plus 2.2 plus d, which is 8.8, divided by s, which is 1. 8.8 divided by 1 is 8.8, pretty obviously. 2.2 plus 8.8 is equal to 11. So that's what we're going to get output on the screen. Okay, now this next one is on explicit casting, and what I mean by explicit casting is we do it. So the computer does implicit casting, and there's 3 ways to cast something explicitly. One is using static cast, so we can say static underscore cast, and then we use square brackets and then say the type to cast to, and then in brackets we specify the thing that we're casting. Okay, and I'm going over my canvas here, so never mind about that. That's one way. The second way is if we say the type to cast to. I'll just say cast underscore to, and then in brackets the thing that we're casting. And then the third way of casting explicitly is by in brackets specifying what we're casting to, and then after that, with no spaces, we specify what we're casting. Okay, so we can see all those down here. So it's also the same kind of numbers as before, apart from D is 6.6 now instead of 8.8 as it was in the previous example. Let's just zoom in a bit more, and you can see I is first of all equal to 2, and then we're dividing that by S, which is a integer 1 converted to a float. Okay, so divided by 1.0, let's just say, to indicate this is being casted to a float. And 2 divided by 1 is 2, and then int of f is 4, and when we're casting a float to an integer, notice that we're completely getting rid of its fractional part, we're not rounding it or anything. So it's 4 divided by I, which is 2, 4 divided by 2 is 2, and then long, remember long is a form of integer with 8 bytes, whereas normal integer has 4 bytes, and a short has 2 bytes. Okay, so just different forms of integer with different memory allocated to them. So we're converting D, which is a double, to an integer, so again we get rid of its fractional part, plus 6 divided by S, which is 1, 6 divided by 1 is 6, so what we're going to get back from this code is 10, okay? Okay, so let's go through this next question, question 11, which is all about characters versus strings. So first of all, we make a string ABC, and we set that to S, so S equals the string ABC, and then what we do is make an integer I equal to 1 to begin with, and then we continue a for loop while I is less than S.length, and S.length is 3 because we have 3 characters in this string, and each time we add 2 onto this to this I variable. So the first time I equals 1, and then later I is going to be increased to 3, but this isn't going to run, okay? So basically I is just going to be equal to 1. And then what we do is we say S at I plus 1 equals S at I plus the little letter A, the little character A minus the big character A, okay? And notice these are characters, okay? So characters use these single quotes, whereas strings use double quotes. So that's the key importance here. And these can be treated like integers, so characters can be treated like integers. And how do we treat them like integers? With ASCII. So the ASCII value of little a is 97, and the ASCII value of big A is 65. Okay, so the difference between these is 32. So this is 32. And it's kind of important really that the distance between little and big letters in the ASCII table is 32 values across, okay? So then what we do is you say S at I, so that's going to be S at 1, which is this B. So remember which is going to be this B. So this is going to be the character B. And when we're sort of subscripting, so we've got a string here and we subscript a value on, then we're going to get a character back, okay? And we're setting S at I minus 1, so S at 0 in this case. So the first S value is going to be B, the character B plus 32, and big B plus 32 is little b, okay, because the distance from the big B to the little b is indeed 32. So therefore we're going to set this one not to A, but to little b. and then when we output it, we're going to output little b, capital B, C. Okay, the next one is about explicit casting again, and it's a really easy one, this one, I think. So we first of all make I equal 2, F equals 5.8, and then we say S, and then we change F to the integer of F, okay? So when we convert float to int, we lose the fraction instead of round it. Okay, so this 0.8 is gone. We can never ever get that back now after we've overwritten our variable f. Okay, so f now equals 5 and I now equals 2.0. Okay, so that's 2.0. This one is 5. And then we do f, which is 5 divided by I, which is 2.0, and that is the result of an int divided by a float equals a float, because we're trying to preserve this fractional part, and we have a fractional part in the calculation to get 2.5. And just for reference, if we try to do 5 divided by 2 as an integer, int divided by an int is an int, and so we're going to get 2 output, okay, which is mathematically wrong. And to properly understand string comparisons, it's a bit more confusing, this function. I've got a little notes page, okay? So the logic of this function, this is from the documentation, by the way, that doesn't really make much sense. By the way, this code here is tiny. I've got it bigger on Replit if you press on the link. So the output is 0 if both the strings are equal. Okay, so if you look at Replit, then you can see in example 4 when S1 equals high and S2 equals high, they're the same. So S1 dot compare S2 is 0. Okay. However, if the contents are the same, so for example, either they are the same, like AA, and so for example, AA compared to AA, or ABC compared to ABCD, well, the contents of these two are the same. Okay, they've both got ABC common to them. Okay, so if the contents of the strings are the same but they're not exactly the same, then it's going to output the first string length subtract the second string length. However, if the contents of the strings are not equal, so one string does not totally appear inside another string, then we're going to find the first character in both strings that does not match, and then what we're going to do is we're going to take the character from the first string and we're going to subtract the character from the second string from it to get the difference. Okay, and notice I'm saying the first minus the second, so it can come out with a negative answer. Okay, so you can have a little read through my examples over here, but for now let's talk about this one. So in this case, then the string's contents are the same. Okay. So in this case, string 1 dot compare string 2 is going to output the difference in length, okay? So in this case, string 1's length minus string 2's length, which is 2, is minus 1. And so we're going to get minus 1 output. Now let's move on to the next question. Another one about pointers, another horrendous one, as if that other one wasn't enough. But this time we've got a vector of strings of t equals alpha, beta, gamma, and then we're making a pointer to a integer, cnt, and it's going to be pointing to, so cnt is going to point to an array of 3 items, okay, each start off at 0, and p is a pointer to an int as well, because we are specifying them on multiple lines, and it's going to point to the first cnt item, okay, so this one. And then what we do is we make a for loop, so I is going to be equal to 0 to begin with, and we're going to continue while I is less than t dot size, and t dot size is the number of items in it, so 3 in this case. So I equals 0, then we're going to increment it to 1, and then it's going to be 2, and then we're going to increment it to 3, but it's not going to run. And we're going to set, this is a kind of confusing part, okay, so we're dereferencing and also incrementing the pointer at the same time. So dereference p, so we're going to set the value that p points to, so this one, equals t at I dot length. T at I is alpha dot length is 5, so we're going to set the value that p points to 5, okay? And then what we do after that is we increment p, okay? So we increment p. So now p is equal to the second item in the CNT. And then we increase I as well, so I is now equal to 1. T at I is beta, and beta dot length is 4. So the value that p now points to is set to 4, and we increase p once more to point to this one. And then we do exactly the same thing. T at I is gamma dot length is 5. T at I is 5, and then p is increased once more, but we're not going to go that way, okay? And then we're going to output the CNT 0, which is 5, 4, and then 5, okay? 5, 4, 5 is the output. Okay, let's move on to the next question. Is again about string comparisons, but just not with the compare function, okay? It's with the operator greater than. Now the difference here is that it's going to check the first character. So it's going to take the first character, which is A, both of them. I'll use my highlighter actually. And it's going to check if S1 at A is greater than S2 at A. We already know the character A's value is 97, and little a's value in the ASCII table is 65, and 97 is indeed 65, so we're going to output yes. So that's the output of that one. Now again, we've got basic data types in question 16. So int I equals 2, string s equals 2, and it's as basic as we just can't concatenate integers to a string. Okay, now back onto concatenation again, and again it's almost the same as before, so hopefully we now know that this is going to be an error because we can't concatenate two strings directly. Okay, so the next question is on multi-dimensional arrays and pointers, another harder one but still not too hard. The first thing we do is we make a it variable, and it's going to point to an array of integers, okay? And these are pointers to integers actually, so I'm going to draw 3 arrows coming out of these right here. And then what we do is we enter a for loop, so I equals 0, then 1, then 2. We can recognise this pattern. And then we set it at I, so that's this first one, equals new int with I plus 1. So 0 plus 1 is 1, and we're going to point to a new array with one integer item in there that we're going to initialise to 0, okay? And then we nested a for loop inside of here, so j equals 0, continue while j is less than I plus 1, so j equals 0 to begin with, so that's, and then we get it at I, which is this one, at j, which is this item right here, equals 10 times I, which is 0, plus 0, it's just going to be 0. Okay, so we set the value of this to 0. And then we increase j, but 1 is not less than 1, so we break out of this for loop. We increase I now to 1, so it at I is this one, equals a new int array of 2 items. So that's going to be this, each with 0 in them to begin with. And then we enter this in a for loop where j equals 0, and then we're going to stop when j is 1. So j equals 0, then it's 1. It at I is here, at j, it's 0 to begin with, equals 10 times I plus j. I keep thinking that's the times, I'll write plus there, but clearer, which is 10, okay? And then when j is increased to 1, then we're going to get access to this item right here. 10 times I, which is 1, plus 1 is 11. So we're going to store 11 in here. That's awful thick writing. Okay, and then j is going to be increased to 2, but 2 is not less than 2, so we're going to break out the for loop, and then now I is equal to 2. IT at I is this item right here. I'm going to make a new integer array with 3 items in it, each a 0 to begin with, and then we're going to have j equals 0 until, and then we're going to have j equals 0 to 2, and IT at I at j is this one, which is 10 times I, which is 2, so that's 20 now, plus j, which is 0, it's going to be 20 right there. And then when we increase j, it's pointing to this item right here, and we set it to 21, and then this one's going to be 22. Okay, and then C out IT at 2 is going to be this one, at 2 is going to be this one, which is 22. Okay, and that's the output of the program. And as I said before, just ignore where it deletes the arrays. Now the next one is again a bit easier. I think it's about string comparisons. We set S1 equals the string AB and S2 equals the string ABC. Now the contents of these strings are the same, okay? So I'm going to say contents are the same. So S1.compare S2 is going to output S1.length minus S2.length to output, once again, -1 to the screen, because 2 minus 3 is -1. And then the last question is about using namespaces, and already we've got one error here because we can't use 2 namespaces at the time. Okay, so cannot so we can't use 2 namespaces with a comma like this, okay? And then we're trying to use these 2 namespaces, each with an A variable in here. And of course that is going to give a conflicting name error. Especially when we try to access A, because it doesn't know which A to access.